Good afternoon. We'll start the 12th lecture in the series of statistics in research methodology. Okay. In the last class, we had discussed the factorial design for the analysis of experimental data, wherein we stopped at this very slide. We had discussed the AIDS method of factorial design in order to analyze data statistically and come to a conclusion whether there is an effect of variation of any of the factor on the response function, wherein we have systematically stepwise derived the values given in columns 1, 2, and 3, and we came to the final conclusion also. And during the AIDS calculations, we had seen that a quick self-check of the entire calculation can be done by the comparison of the value given on the top row of the third column and the bottommost value in the second, that is response values. If they are matching with each other, that means your calculation is right till that point. From those calculations and final results, we concluded that during the absorbance measurement of calcium using atomic absorption spectrometry, the flame height is the most important factor governing the entire response function, because it has got the highest impact on the response function as per the total sum of the squares is highest for that factor. We had a defined factors, levels, and response. Factor is the one which is contributing to the change in the response function. Levels have the various values will be manifested, and the response is the observed parameter, observed measured value. And we had defined A as the flame height as the A factor, the lamp current as the B factor, and ratio, fuel to oxygen ratio as the C factor. The same definitions hold here too as the effects of factors A, B, and BC. That means flame height, the lamp current, and combine the factor BC are holding negative signs. You can read from the column 3 of the AIDS calculation on the left side of the left side table. A, B, and A, BC, A, B, and BC. These three are having negative sign in that column number 3. That means the response is lowered when you increase these factors to their higher levels. When you increase the higher level to their higher levels, the response is inverse. That means they have got a negative impact on the response function. And you can easily see that factor C, the value of 4C is 76. Factor C has got a positive sign. That means as factor C goes to the higher level, definitely the output or the response or the absorbance value of calcium goes to higher value. That means it is favored when you go to the higher level of factor C. So ultimately, from all these calculations, we come to the conclusion that low flame height and the low lamp current, along with high fuel ratio, would produce the best results for the combinations of flame height, say 15 to 25 millimeter, lamp current of 2 to 3 millimeters, and fuel ratio 4 by 9 to 5 by 9. Then you can say that flame height of 15 millimeter is the better option compared to the other one. Lamp current of 2 milliampere and fuel ratio of 5 to 9. This will be the best combination among all those we tried during this evaluation. Further, from the factorial analysis of experimental data, we can infer whether the factors they do have interaction between themselves or not. From the same set of results, we can infer this also. How do we go about it? That we'll discuss in this slide. Actually, whatever we have calculated till now is the sum of the squares. So this gives the impact of factors and their interaction on the final results. Now, as we proceed in the F test or variance ratio test, what we do is take the ratio between mean square of the factors to mean square of the errors. Here again, the same procedure holds. We will now calculate the mean square of the errors. Since we have done two replicate measurements for each of the 8 combinations, then we will see 16 such results, such response functions should be there. And we can do the residual sum of the squares calculation simply. The entire calculation is shown here. It can be calculated as a sum of the squares of each value in the columns 1 and 2. Then subtract the sum of the squares of each values in column 3. Then this subtraction function should be divided by the total number of replicate measurements. The entire calculation is numerically also shown here, from where we derive the residual mean square to be 11. Here the degrees of freedom is 8, because each experimental value is derived from each factor values are derived from 2 replicates each. So 2 minus 1 will be the degree of freedom for one mean. So like that, 2 minus 1, 2 minus 1, like that we add up to 16, then we get 16 minus 8. That is 8. 8 degrees of freedom are there for the residual sum of the squares or the error sum of the squares. The same way we did for the F ratio calculation, here we do the division of mean sum of the squares with the residual sum of the squares. Then we compare the calculated F value with the critical F values in the table for the corresponding degrees of freedom. Then, for example, if we are studying the interaction of effect of AC and factor B, then we can see that the F value, calculated F value, comes out to be 9.09. So from the F table, if you go back and refer to the F table, you can see that the F values for 1 and 8 degrees of freedom will be 5.32 for 5% significance level and 11.3 for 1% significance level. As the value 9.09 is larger than 5.32, we can say that the interaction effects are significant at 5% level, whereas at 1% level, there is no interaction. That means at 1% level, the values seem to be statistically identical. But if you put the significance level as 5 for F calculations, then you say that yes, they do interact among each other. You can easily see that the flame height, fuel ratio, both are highly significant as their F values are greater than 100. Definitely, if you evaluate even at 1% or still lower value, definitely they have the significant impact on the final absorbance measurements. Now we can conclude that the flame height and fuel ratio are the two major factors controlling the absorbance measurements. The lamp current has got significant, substantially small contribution in that. Having concluded that lamp current is not significantly affecting the final absorbance, we can modify the procedure in such a way by optimizing the flame current and the fuel to oxidant ratio. So from previous experience of analysis, we have seen that lamp current at low value, that is 2 milliampere, gives better output. So let us keep lamp current at 2 milliampere and try to carry out the experiment in the other. So now that we have fixed one factor, the total number of experimental combinations come out to be 2 to the power 2. 2 levels, 2 factors. That will be 4. Those are given the symbols R, P, S, and Q, where R stands for low values of both A and C contributors, P for high level of A, C where at P point the C value is low. Similarly, S and Q, the descriptions are given in the factors column. Then the treatment combinations wherein we keep all the values low, and when A and C are low, definitely the chances are that B is there. B can be high also. B can be high as well as low. Then when we keep the A factor, that is flame height at high level, the treatment combination which will be affecting the which will be giving the response will be A and AB. Similarly, when we keep the fuel to oxidant ratio high, that is the C factor high, then the treatment combination corresponding to this high fuel ratio contribution will be C and BC. Similarly, the point Q can also be described in terms of the treatment combination, and the measured response for an example calculation is shown over here, and their mean value is as usual calculated. Now that we have seen that the factors can have inter-factor interaction, let us see how we can evaluate what will be the contribution from the inter-factor interaction on the response function. We have seen that at 5% significance level via the F-test, AC factor, that is interaction between flame height and fuel oxidant ratio, has got significance. That means they are changing the absorbance visibly. And alternatively, we can graphically also state the same thing, which will be more appealing to the third person. Let us see how graphically we can represent. For example, if we are changing the flame height from low value, that is 15 millimeter, to high value, that is 25 millimeter, keeping the fuel ratio at low level, then the change in the flame height from 15 to 25 millimeter and the fuel ratio 5/9, that is a high level. From the graph, we can read that as we change from 15 to 25 millimeter, you can read that the line representing that flame height, the value correspondingly comes down. Definitely, flame height has got a negative impact on the response function, absorbance value. Whereas if you go from 4/9 to 5/9, that fuel to oxidant ratio, you see that the line is having a positive slope, upward slope. Definitely, it is having a positive impact on the final response function. In this graphical representation, if you see the final response function as the factor of flame height as well as fuel ratio, it is very visible that both the lines are not parallel. They are not additive, meaning they have some interaction among these two factors. The lines are not parallel. That means these effects are not additive. Definitely, these are interacting one another and modifying the final output. Another example in the same context, we can see whether the flame height and lamp current, whether they do have inter-factor interaction or not. The same way as we proceeded for A and C, we can see between A and B, flame height and lamp current. Similarly, graphically, we can represent, since both are impacting adversely to the absorbance, you can see the line is having negative slope, as well as you go from low to high value of the flame height, then again you see there is a decrement in the value at each and every point of the output graph. However, you can see the lines are parallel. That means they are not interacting. They are not either getting added up or getting subtracted up. They are independent of each other. These conclusions could be made with the help of this F ratio test and the factorial analysis combined via the Yates method as well as the graphical representation. So these are the utilities of statistics in analyzing data and gathering information. And further future, you can proceed with keeping the lamp current at low value and going for low flame height. Even still lower flame height, one can try whether it is giving a better output or not. And at the same time, fuel to oxidant ratio also one can try to modify, try to increase and see what will be the impact. That way one gets an idea which factor to be concentrated upon to get optimized output. So now we come to the optimization of experiment after getting inferences regarding the data, regarding the output factor as a function of the input factors. So here what we do is do the factorial design, get an idea and identify the major contributing factors and whether they are interacting among each other. Whether they have interaction, cross interaction, that means you have to study combined effect. it will be a simultaneous optimization. We had seen sequential and simultaneous optimization. When we have interaction among the factors, most of the time we may have to do simultaneous design of the experiment. And while optimizing the outcome, we can give focus to those factors which will be leading to substantial changes in the response function. Those which are not affecting much, wherever the F values are less than the critical F values, F ratio, those you can neglect and go ahead so that you can save time and energy. Then during the optimization process, if you do this elimination at each and every step, your optimization method becomes simpler and simpler. So the procedure, it is a sequential elimination of the negligible factors at each and every level. It is called a simplex optimization. In linear programming and all, it is regularly used as simplex optimization, wherein we do assign a geometrical figure where the number of vertices of the geometrical figure is one more than the number of factors. For example, if we have got 2 factors, the geometrical figure will be a triangle. If we have got 3 factors, it will be a tetrahedron. More than 3 factors at a time can be considered, but in order to visualize them in 3D space, it will be difficult. So for us to understand, what we will do is, we will take simpler example of 2 factors and try to elaborate this concept of simplex optimization in the coming slides. Fundamental idea during the simplex optimization is to reach the optimum output in a sequential stepwise fashion with minimum number of experiments. With minimum efforts, how can we reach to the top level, optimized output? That is what simplex optimization does. Here it is a systematic procedure, stepwise procedure. Wherever you find a factor is affecting, give focus, give attention, give due importance to that factor. Try to modify that factor according to the impact visible in the factorial design. So be smart enough to take decision at each and every step. Though it is sequential, you can save many of the input factors, and maybe you can optimize the time and get with the smart outputs. And the interpretation also will be easier if you have a handful of data rather than a large population. It will be easy for you to combine them, club them together, understand and express in a meaningful way to the other person. In simplex optimization, the procedure will be like this. We move from the regions of poor response, that is a poor output, to the regions of the optimum response via a smart decision of eliminating lower contributing factors at each and every step. This is achieved by stepwise replacement of points of poor response in the graphical representation I will show you, with their mirror images, that is their reflections on the lines, which is defined by the other points. For example, if I have 2 factors, fuel height and flame height and fuel ratio, we will have a simplex, that the same example we will see, and the output will be shown. Wherever you get a lower output, you eliminate. It will be like this. The input factors, your flame height and fuel ratio, x1 and x2. Say x1 is flame height, x2 is fuel ratio, are taken on the 2 axes. You can take either of them in the axis. Then you plot the response. This area will be the response region for response function representation. And you see, among those, whichever is the lower value, say this, if this is the lower value, you take a mirror image of that value, or that the line of line or mirror will be the line joined by the other 2 points. Whichever value is lower, exclude that one, make a line joining the other for the 2 factor simplex optimization. Now you have reached the response function which is better than the xj. Now xj star is better than xj. Like that, when you have this triangle, the upper triangle, you see that now this point is having the poorest response. Now you focus on improving this point. You make a mirror image of this point on here. So that way you reach at this point. Now, this point is at lower value. It is reflected over here. So that way we climb up the hill without any previous understanding, without any previous direction. We are making our own pathway to reach up to the top of the hill without any help of an external agency or external body. There is no map to lead us to the final point. Our target is to reach to the top of the hill. That is the idea of simplex optimization, and these dotted circles represent those regions where we get identical responses. So that way the optimization goes uphill systematically, and the steepest possible ascent we will do, so that we get minimum, we have to do minimum number of experiments and we get the output. We get to reach to the top of the hill. So these are a set of rules to be followed while doing the simplex optimization method. This is the simplest way of representing the optimization method using two factors affecting the final response. After recording the response, a move is made. Definitely a move will be made. And in simplex is the one geometrical figure having one number more vertices, one more number than the number of factors. So if you have two factors, it will be a triangle. And after forming the simplex figure, you see that whichever is the lowest response, whichever is the lowest output, take a mirror image of that, as I told you in the previous slide. Then this new point will show a better response than the previous one, whichever is rejected. So if at all, if the new point is having a worse response than the previous simplex, what you will see is that ultimately you will be moving around a loop in the same simplex. So that means it will be halting at that point. Simplex will not improve further much. That time you go to the third rule, wherein it says that if by excluding the worst response function by making reflection of it is not improving, then you leave the poorest response function, go to the next worst response, try to do the mirror image of that one. Next worst response, try to take the mirror image of that one. That way you try to optimize the simplex. Though it looks like a bit difficult, tedious process, it will lead to the top of the response function, that is the optimum response function in the fastest possible way. That is the real beauty of the simplex optimization. This is the basic simplex method. There are modified methods available now, wherein in addition to the reflection, expansion and contraction functions are also added. That will be a bit more complex compared to this one. Definitely, some statistical softwares will help us to do that entire job in a more easy manner, because these are a bit involved calculations. If at all you find that during the optimization, a point is falling outside the boundaries defined by the triangle, the boundaries of the original triangle, then reject it. These are the points where you utilize our previous experiences with the outliers, as we have seen the F ratio, all those functions whichever we learned till date will be being utilized during this optimization. And finally, how to conclude whether you have reached the top of the hill, the final optimum response or not. If at all one response point is retained in n+1 simplexes. For example, here 2 + 1, 3 simplex. You will see that if at all 3 simplexes a point is being retained, then that means it is the most optimum output. Otherwise, it will be like the simplex vertices may be within the predefined confidence intervals. That also will suffice. If at all you are not able to retain a single point, maybe if you can reach to a point where the vertices are within the predefined confidence interval level, then you can come to the conclusion that yes, we have reached the optimum of the simplex method, the optimum via the simplex method. There are no shortcuts to reach to the top. You have to be a hardworking person, then only you will reach to the top. But definitely systematic way, if you work, you will reach in the with the minimum effort. The steepest action can be achieved. Now that we have understood there are several calculations involved, it is very difficult to do manually. So people take help of statistical packages so that all this analysis can be done via the help of computer programs. So there are various programs available in the internet, you will see, and those which are very, very useful and used in the research field, those only I will summarize. If you go to any website, you can see a list of freely available and this thing. Paid packages, all will be proprietary packages, all will be available. Some may be add-on package also. A few of them which are relevant to our requirements, those only we will discuss today. So by using statistical package, definitely we are going to get improved efficiency, accuracy, user friendliness, and you can have a check any time of your requirement. You can go back and check. So data management, data retrieval, analysis, all these are possible. You can redefine the data. Everything will be recorded. Whereas, and the third person can also have a cross check. You can visualize them, graphical interfaces are available, and the comprehensive features which will help us to make the conclusion more substantial and vivid. So a few of the commonly used statistical packages are listed over here, which most of us during our research may be utilizing. For example, R, SAS, SPSS, Stata, JUMP, MATLAB, Minitab, and the simpler one, Excel, Microsoft Excel, and AP Info. These one only we will elaborate their origin, what is their utility, and a few of their functions which will be very commonly used by us during research and analysis. These are not, this is not a comprehensive list, I agree, but these are the ones which may be helping us during research and analysis. So we will just see one by one their a bit of history, their introduction. I will just introduce you to these packages and leave. All of you can take help, and you, many of them like R and Excel and AP Info, these are freely available open source packages. Or anybody can have their tutorial, download these programs, have their tutorials done. They have example programs also. Let's get practice and utilize. These are very powerful tools. So R is one such program. This is used by environmental scientists as well as population scientists, and the origin, the scientists who discovered this program are written here. It is a free open source program, so it is not to be paid to download this program. It is mainly used for data mining, informatics, and data analysis. Then the origin of the name R is from the name, first letter of the scientist who had done this program development. This Rosie Haka and Robert Gentleman. They were the two scientists who had introduced this packet. This is a successor of the S language already existing, and it has got its own command line. It works on DOS system generally, or you can do program in C, Fortran, or even in R itself and do the exercise. The tutorials, R tutorial, R Studio is there. You can go to download R Studio and get practice, hands-on practice on that. If you have any data available, you can have a try. Even the worked out examples will lead you to follow them, how to do the entire process. So it is open source as I already told. So if anybody has got ability to do coding language, they can make programs and customize the R software as per their requirement and utilize, so that the interface can be created and the data analysis can be made easy via this R project. So I recommend all of you to try to give a try to download this one and go through the features listed in the help menu also. But wherever possible, you try to make use of at the beginning of your research itself, so that later on when you have compilation of large data, this program will be of use to you to do the entire data analysis. Another software is SAS, Statistical Analysis System. This is a proprietary software. You may have to pay for downloading it. It was developed in 1966 by a particular institute. I will not name the institute. This also is used for research purposes by many agencies for analyzing data, and whenever we have multivariate analysis, whatever we did was univariate analysis, single in the simplex and factorial design. We are changing one factor at a time and trying to understand the impact on the output. Whereas if you are doing simultaneous design of experiment, you may have to do multivariate analysis, and the complexity starts increasing. So SAS is a cloud-based platform to provide ready-to-use programs for all these data analysis, manipulation, and storage and retrieval. And there is a corresponding open source DAP software, which is almost similar to this SAS. One can go to that one and try to understand if possible. If you require any such this data analysis to be done, which is possible by SAS, you can do using DAP software also. And the attractive features of SAS are listed here, and it has got many add-on packages also as per the requirement. If you want to do the statistical analysis only, SAS Stat is there. If you want to represent graphical representation, add-on packages one can buy, like graph or a particular research area. There are several such add-ons available on payment basis for this software too. This statistical package for social sciences, this is also a payable software. This is used by population scientists and social science people generally. It is one of the oldest statistical package, maybe the first and foremost packages used by people. So it is very easy, very simple for any person can do that one. The process, the features are like very easy to learn and use. Any layman can do. Whereas R and all, you should have some preliminary programming knowledge so that you can get familiarized with the package much easier. Whereas SPSS is much easy to adopt. One can easily, just like reading a storybook, you can go through the help and tool menu. You can get comfortably go through the guidelines and come out with the data analysis and final outcome. So it can be used in any syntax or menu. There is no restriction for using in a particular platform only. Graphics are also visibly good. Then it can be used for descriptive statistics, as well as regression, correlation analysis of variance, whatever we discussed during the previous all lectures, all can be done. Where when you are handling large volume of data, this SPSS comes very handy. And it has got its own structural equation. Even modeling software is also available along with SPSS. Depending on the requirement or the context, you can choose to work with any of the softwares listed over here. In addition to this, there are many others. If at all you are already using any data, any special package which will be useful for your particular purpose, keep doing that one. If anybody is new to this usage of statistical package software, you can try with all of these one and come out with the one which will be helping you most. Okay, then Stata is also a part of add-on program for SAS, as I told you. Here again, depending on the requirement, the program can be optimized and you get the final reporting, even up to the final reporting format, one can get the full results. So in healthcare, social sciences, this data software is used. Statistics and data is the full form of that one. It is relatively newer version compared to SPSS and other softwares. So since it is very easy to adopt, it is increasingly popular in the areas of medical and economic fields. It is very good in those cases where the syntax or menu files are of various different streams. You can use it. It is more powerful than the SPSS, the previous statistical package, and almost equivalent to SAS. So if you are not familiar to use SAS, you are not able to purchase a SAS, you can have a compromise and go ahead with the Stata. Then it is useful for regression modeling, and it has got similar to that SPSS structural modeling is also available for Stata and epidemiological procedures. These people are increasingly using Stata for their data analysis. Another software is JMP, JMP. It is pronounced as JMP. It is also used by various people and scientists and engineers, which is mainly governed by artificial intelligence and machine learning. JMP Institute is the origin source of this program. This program was launched in 1989 to take advantage of this graphical user interface introduced by this Macintosh operating system. JMP is a JMP, it is pronounced as JMP. JMP is a desktop software to suit all levels of analysis. So you can see a comparison between all the software and take judgment and come to the one which will be used, most suited. MATLAB is used by many scientists regularly for graphical representation of the output, especially when you do the factorial design and try to show up the results of response function as a response as a function of the input factor levels. MATLAB is regularly used by many people. It is easy that the programs are already available. You have to only feed in the date factors, levels, and the number of replicate readings. It will calculate the F value and their output data, the predictive analysis, interaction effects. All those things are easily done via MATLAB, and you get graphical representation also. Similarly, another software is Minitab. Same functions can be done. Depending on sometimes the requirement of the operating system, you can choose between these two. There is another software called Statistica also. That also serves the similar process that is not included here. Microsoft Excel is the most common one. It is not actually a statistical software, but it has got many add-ons so that it can serve the purpose of doing the analysis via its original features. So simple calculations and computations, people use regularly the Microsoft Excel. Further, it can do the graphical representations, pivot tables, and macro programming languages, and connectivity between other programs. So that way data can be exchanged, data can be taken, or data can be transferred also to the other programs. So one can, according to the requirement, one can choose between all the softwares which we discussed till now. The latest version Excel 2024 is also available for download. One can do that one and see the features in the help menu and go according to those one. Wherever you find that you want to add on function, there is provision to do that also. So generally, the descriptive statistics like average, mean, median, standard deviation, variance, minima, maxima, count of the number of parameters, number of variables, all those things are can be easily done by the tool of Excel. The basic Excel functions provide all these values. And as we discussed repeatedly in hypothesis testing, we do the T, Z, and F test. The functions names are also listed here, so that if you want to test the whatever data we discussed till date, you can take help of Excel and try to do the T, Z, and F test via these functions also, and cross-check your values with those obtained during Excel evaluation. That way you get confidence in usage of all these packages also. And correlation regression analysis also are available. We had seen basic and weighted regression. There are options to select between these also. And if you want to add on any of the functions which you will define and give it to, these are also available. How to do that add-in functions, those steps are given here. Go to the file and follow all the steps. Help menu will guide you through how to do that. And nowadays you people are familiar with internet. They will, like YouTube also will provide you how to do all these once you load this add-in tool pack, you can use it frequently. So as per the requirement, take help of the help menu and YouTube videos. You will be able to do all those things. These are the features which are available in Excel: pivot tables, charts, graphics, conditional formatting, and analyzing data. All these factors, these features will help you to do whatever we discussed till date in the class. This is another general software used by healthcare medical people regularly. For example, epidemiologists use for the analysis of diseases, control and prevention of the diseases. This was originally used. There are add-on packages for EpiInfo, like EpiData and the EpiValidation. There are add-on packages available for this software also. For all those softwares, I had given on the top their logo so that you can easily identify them, download them. Those are the authentic logos. You can get to verify it and download as per the requirement. And these are like even in mobile based systems also, these softwares work. So these are handy. You can utilize anywhere and everywhere. Now let us come to the conclusion slide. We had whatever topics we have discussed, all are listed here. We started with the role of statistics in daily life as well as research. Then we had seen the various physical quantities, discrete and continuous variables, their measurements, the quantity being measured, which is called a measurement, the factors affecting these measurements, measuring tools, the personnel involved, and the environment in which we do the measurement. Then we had seen how effectively one can represent the results of the measurement so that the third person can appreciate and make use of it for their own purpose. Furthermore, how to improve the quality of the data via expressing the accuracy and precision of the measurements. In connection with precision of the measurements, we had seen significant figures, place value of digits, rounding off, error propagation, and rules to each and every factors listed in this line. Then we had seen the types of measurements like gross, systematic, and random errors, defined them, their sources, ways to tackle them. Then we had seen that random errors are inevitably attached to any measurement. The efforts in the efforts to minimize the effects of random errors, repeated measurements, we had understood the properties of Gaussian distribution function, confidence interval, confidence level, and confidence limits were defined and utilized to understand the limits within which the true value will be lying with respect to the measured value. Discrete and probability distribution functions of various kinds were described, and their statistical parameters like mean and standard deviation and variance were also defined theoretically and mathematically. Hypothesis testing were initiated with sedentary statistics. We understood the type 1 and type 2 error which may be committed during the hypothesis testing, how to overcome that, what is the level to be set for both of these types, and the steps, systematic steps for carrying out the hypothesis testing in the form of a flow diagram we had seen. And the minimum number of replicate measurements to get quality data and reliability interval to define the number of replicate measurements along with the significance level as well as the level of concentration or the value level of the quantity to define the reliability level. The chi-square test and the F test, that is variance ratio test, were defined, and a few of the examples were also carried out during the lectures, and a few were given to you for as a homework. Then analysis of variance and extension of the F ratio test for product moment correlation coefficient. Further, the t-test for testing the correlation. Wherever you find correlation coefficient is not able to give us power to take a decision. Then the regression analysis via ordinary as well as weighted regression, presuming that the errors are occurring only in the dependent variable. Then the least significant difference, when we did the F ratio test, we found that there is a significant difference between two sets of data. To find out which one is causing the difference, that least significant difference method via the paired t-test were done. Then the other parameters like skewness and kurtosis of natural data, which will lead to asymmetries in the distribution of continuous variables. Then we had seen if at all you have a choice to select between two hypothesis tests at a particular juncture, the power of the hypothesis test will guide you to decide which test to be conducted at certain point. Further, in the last two lectures, we understood how to effectively design an experiment so that with minimum efforts, you come out with quality results. Then chemometrics were introduced, factorial design of experiments, analysis of already available data. The steps involved in the calculation were described via the AIDS method and graphical representation. And the most easiest way to arrive at the optimum output via the sequential simplex method of optimization of experiments. And finally, we got just introduced to various statistical packages available, the way to approach all these packages and their utilities as far as statistical analysis of data are concerned. These are the topics we discussed during these 12 lectures. If anybody has any doubt, you may please write in the chat box. If not today, you may contact me via email, which was given in the very first lecture, wherein phone number is also given. Phone number, email ID, both are given in the very first lecture. And along with those, I had given a list of references for you. If at all you want further information regarding this application of statistics in your field of interest, you can go through those references which were given in the first lecture slide. My contact number, email ID, and list of references were given in the very first lecture. You may refer to those one. And summary of all the topics covered are given in the last slide today. As there are no doubts written in the, I am not seeing any doubt in the chat box, any comments, no comments are written in the chat box. So let us wind up. Let us wind up for the day. You may contact later if you want any clarification. Okay.